All right, so this is a review on solving exponential equations using the same base. And so if we look at number one, we have this. We have 9 to the x plus 3 power equals 27 to the x minus 5. And so notice that this base here is 9 and this base here is 27. So the base is not the same, but we can get them to have the same base. So remember, one of our properties indicated this, that if you have b to the a power equals b to the c power, as long as these bases are the same, the exponents have to equal. So a must equal c. And so that's the idea we're going to use here. So I want you to notice that 9 and 27, I can rewrite 9 and 27 as a different base than what you see using another base. So in other words, I want you to remember 9 we know is 3 squared, right? And then 27 we know is 3 cubed. So notice that these bases are the same. They both have base 3. So I'm going to rewrite 9 as 3 squared, all raised to the x plus 3 power. And make sure you put parentheses here. That's going to be important. Equal, and then 27 is 3 cubed, all being raised to the x minus 5 power. Again, parentheses are important here. And the reason why parentheses are important, because now you're going to get rid of the parentheses, and notice that when you have a power raised to power, you multiply. So all of these terms here are being multiplied by this 2. So this becomes 3, and then you're going to distribute the 2 here, so it's 2x plus 6. 2x plus 6. Both of those terms be multiplied by 2. So 2x plus 6 equal, and then the same thing here. So getting rid of the parentheses, you have a power raised to power, so you're going to multiply those exponents. So that becomes 3 to the 3x minus 15. And now we have an equation with the same base. So that means that these exponents must be equal. So we just set those exponents equal to each other, just like this, and we solve for x. So we have this linear equation, so I'm going to go ahead and subtract 2x from both sides. So I get 6 equal 3x minus 2x is x minus 5. And then now just getting x by itself, we're going to add 5 to both sides. Combining like terms, I get x to be 11. And so that's your solution. So x to be 11. All right, in number 2, we have 1/2 to the 4x minus 1 equal 8 to the 2x plus 3. Now, notice that this one has a fraction in it. You see that 1/2. And I want you to think of it this way. You can get those bases to be the same very easily by thinking like this. You know that 1/2 is 2 to the negative 1. And you know that 8 is 2 cubed. So now notice I have those bases to be the same. And so I'm going to rewrite 1/2 then as 2 to the negative 1, and that's being raised to the 4x minus 1, equal, and then 8 I'm going to rewrite as 2 cubed. So that's 2 cubed, and that's being raised to the 2x plus 3 power. Now getting rid of the parentheses, remember you have a power raised to power, so you have to multiply this, so that's negative 1 times both of those terms, so be careful. This becomes 2, negative 1 times 4x is negative 4x, and a negative 1 times a negative 1 is a positive 1. So that was a mistake that you could have easily made here. Equal, and then do the same thing here. So it'll be 2 to the 3 times 2x is 6x, and then 3 times 3 is 9. And so now, since the bases are the same, I can set those exponents equal to each other. So negative 4x plus 1 equals 6x plus 9. Let's go ahead and add 4x to both sides. And so since that's a linear equation, I'm going to have 1 equal, that's 10x plus 9. And then subtract 9 from both sides. Combine like terms, I get 1 minus 9 is a negative 8 equals 10x. Divide by 10. I get x to be reduced. This becomes negative 4/5. And so that's your solution there. All right, so that was a quick review of solving exponential equations where we get the same base.